Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next problem on gamma functions, and that is from type 2. First, what is gamma of n? Gamma of n is nothing but 0 to infinity e raised to minus x and x raised to n minus 1. So this is the formula of gamma of n, and the question is evaluate this integral. As you can see, this integral has log term, so this integral is of type 2. So in type 2 our integration is from 0 to 1 log of x the whole raised to m into x raised to n dx. So our this problem is of this type, that is, as we know, this is type 2 problem. Whenever there is log, it is a type 2 problem of gamma function. So we will represent our this equation in this form. So we are going to represent this as integration 0 to 1 dx whole square root we can write as x raised to half log of 1 by x the whole raised to half. Okay, if I take both these terms in the numerator, we can represent this equation in this form, which is this x raised to half. When it goes in the numerator, it becomes minus half. Let's say this is our I. And similarly, when this term goes in the numerator, it will also become minus half and dx. So now our question becomes this. So for that, we need to evaluate this integral, or we have to represent this integral in this form. To represent integral in this form, we have to substitute this log of 1 by x. Instead of log of 1 by x, we need some e raised to term. So we are going to substitute something for log of 1 by x. Let's say we substitute 1 by x equal to u. Then, so we will substitute log of 1 by x equal to u. If I take this log on the right hand side, it will become exponential e raised to u. So if I take x in the numerator or I take this in the denominator, if I cross multiply or do something, x will be equal to e raised to minus u. So this is our x, but here we have to replace all the terms which contain x. So this x can be replaced by e raised to minus u. But what about this dx? For this dx we need to derivate this x. So we take derivative of x. Derivative of e raised to minus u is e raised to minus u and minus sign into du. So we will replace log 1 by x by u. We will replace x by e raised to minus u, and we will replace dx by this term. So our equation become this. But what will be the limit of this integration now? Earlier, the limit was 0 to 1, but instead of x, we are substituting e raised to minus u. So our limit of this integration will also change. To find the limit, we will make one table. So in this table, here we will write old variable. Here we will write new variable. So what is old variable? Old variable is x. What is new variable? New variable is u. In old variable, x is 0 to 1. So we will write these values. Okay. So in old variable is x and old variable is from 0 to 1. To find the new variable, we will consider relationship between old variable and new variable. So the relationship between old variable and new variable is x equal to e raised to minus u. So we need to find the value of u. So we will write equation in terms of u. If we take here, it will be log of 1 by x. So if we put 0, and log of 1 by 0 is nothing but infinity. So u will be infinity. And if we put x equal to 1, it will become log of 1. And log of 1 is nothing but 0. So our new integration limit is from infinity to 0. So our integration limit is infinity to 0. Now if I take this negative sign here, our equation will become, in this e, consider this e. This minus and minus will become plus, and this u and multiplied by half will become u by 2. And this u raised to minus half remain as it is, and this e raised to minus u into du. And we know that whenever we have integration limits, let's say limit 1 to limit 2, if this is, so this is our some limit equation. Okay, when we take minus sign, and we can neglect this minus sign by changing the limits from L2 to L1 by making it as positive. So here also we will take this negative sign into the integration, and our limits will be now from 0 to infinity. Why we need in limit 0 to infinity? Because we need to represent this in gamma function form. Okay, that's why we need in limits from 0 to infinity. For that we will take this negative sign into the integration. When we take negative sign into the integration, our limit of integration will be changed.